Dear students, under the lecture series on complex analysis, we are solving problems under the topic Taylor series. The question here is find the Taylor series to represent z square minus 1 divided by z plus 2 multiplied with z plus 3 in mod z lesser than 2. Now, in order to solve this, first of all, we have to expand this by using partial fraction. Now, how to do that? We will write the given z square minus 1 divided by z plus 2 multiplied with z plus 3. Now this has to be expanded into partial fraction. In order to do that, first we have to observe the degree of the numerator and the degree of the denominator. So when the degrees are equal, then it can be splitted up as by adding a constant and followed by, for example, here in this problem, now since the degree of the numerator is 2 and the degree of the denominator is also 2, because here we have z and here also we have z, so on multiplication the degree of the denominator will be 2. So which means the degree of the numerator is equal to the degree of the denominator. So in such case, this can be splitted up as a plus b divided by the first factor, which is z plus 2, plus c divided by the second factor, z plus 3. So this is how we have to split up using partial fraction whenever the degree of the numerator is equal to the degree of the denominator. Now taking LCM on the right, we will be getting, here we have z square minus 1 to be equal to a multiplied with z plus 2, okay, multiplied with z plus 3, plus b multiplied with z plus 3, plus c multiplied with z plus 2. This is by partial fraction, and the denominator will be z plus 2 multiplied with the z plus 3, which will get cancelled since the denominator of the left hand side is also the same. So we will be left out with this. So now here we have to find the values of a, b and c now. Now first we shall find the value of c, for which we should make a and b, that is these two terms, as 0. So we have to put z is equal to minus 3. So first is we put z to be equal to minus 3. So what do we get? Minus 3 square minus 1 is equal to, so this term becomes 0, because when we put minus 3 plus 3 becomes 0 and the whole term becomes 0. And in a similar way this term also becomes 0, and here we will be having c multiplied with minus 3 plus 2. So on the left we have minus 3 square is 9, minus 1 is equal to c multiplied with minus 3 plus 2 is minus 1. So from this we get 9 minus 1 is 8 is equal to minus c, and from that we get c to be equal to minus 8. So this is the value of c. Now we shall find the value of b by putting the other one, that is by making these two 0, so that we have to put z is equal to minus 2. So put z to be equal to minus 2. So from this we get, when you put minus 2, it will be minus 2 square minus 1 on the left to be equal to, when you put minus 2 here it becomes 0 and the whole term becomes 0. So b multiplied with minus 2 plus 3, and c, this also becomes 0 because minus 2 plus 2 is 0. So from this we get minus 2 square is 4, 4 minus 1 is 3 is equal to b multiplied with minus 2 plus 3 is 1. So therefore from this we get the value of b to be equal to 3. Now in order to find the value of a, we shall put z to be equal to 0. So from that, when you put this as 0, so 0 square, which is 0 only, so minus 1 is equal to a multiplied with, what is z? Z is 0, so 0 plus 2, so 2 multiplied with 0 plus 3 is 3, plus b multiplied with 0 plus 3 is 3, plus c multiplied with 0 plus 2 is 2. So now from this we get minus 1 to be equal to 3, 2 times is 6a, 3 plus 3b plus 2c. We know that b is equal to 3 and c is equal to minus 8. So in this we will substitute that. So minus 1 is equal to 6a plus 3 multiplied with b is what? 3 plus 2 multiplied with c is minus 8. So therefore what do we get? Minus 1 is equal to 6a, and this is 3 times is 9, plus into minus is minus, 8 2 times is 16. So from this we get minus 1 to be equal to 6a, and 9 minus 16 is minus 7. So from that we get, we will have 6a as it is. So minus 1 plus 7. So therefore we get 6a to be equal to 6, and so therefore the value of a is equal to 1. So this is the value of a. We have obtained the value of a, b and c, so that we can substitute in this. So after substitution this turns out to be, so z square minus 1 divided by z plus 2 multiplied with z plus 3 is equal to a is 1 plus b is 3. So plus 3 by z plus 2, and c is what? Minus 8. So is minus 8 by z plus 3. So this is what we obtain after splitting up using partial fractions. Now from this we will obtain the Taylor series expansion. So this can be written as 1 plus 3 by 2 plus z minus 8 by 3 plus z. Just I am rewriting it. Then we can write it as 1 plus 3 by this 2 when taken out, it will be 1 plus z by 2. And then minus 8 by, when 3 taken out, it will be 1 plus z by 3, because we have taken 2 out. Now if you multiply and see, we get back this one. So we are just rewriting it in this manner so that easily we can split it up as a series. So now, so further this can be written as 1 plus 3 by 2. We will raise this to the numerator, so it will be 1 plus z by 2 the whole power minus 1 minus 8 by 3 multiplied with 1 plus z by 3 the whole power minus 1. Now we can expand this by using the binomial series formula, which is 1 plus x the whole power minus 1 equal to 1 minus x plus x square minus x cube plus x to the power 4 minus etc. So this formula we are going to apply for these two terms. So when we apply, what do we get? So in this, at the place of x we are having z by 2, and here at the place of x we are having z by 3. So we shall start to expand it. So this will be equal to further 1 plus 3 by 2 multiplied with, now this we have to expand by using this series. So it will be 1 minus x, x is what? Z by 2, plus x square, so that is z by 2 square, and then minus z cube, so z by 2 cube. So and this goes on like this, and then minus 8 by 3 we have, and within the bracket again this we have to expand by using binomial series formula, where the value of x is what? Z by 3. So when we expand, how do we get it? First is 1, then minus x, so x is what? Z by 3, and then plus x square, so plus z by 3 square, and then minus x cube, so minus z by 3 cube, plus etc. It keeps on going like this. So now we can simplify this as 1 plus this 3 by 2 we will multiply inside to each of the terms. So it will become, so here in this when you multiply it with 1, it becomes 3 by 2 minus 3 by 2 multiplied with z by 2, which will be 3z divided by 2 square, and 3 by 2 multiplied with z by 2 the whole square will become plus 3, numerator will be z square, and the denominator will be 2 to the power, already we have 2 square here, when multiplied with 2 it becomes 2 cube, and then minus 3 by 2 multiplied with this term, so 3 is z cube divided by 2 multiplied with 2 square is 2 power 3, and then plus etc. Similarly, what about this term? This has to be multiplied, this 8 by 3. So on multiplying this, it will be, since we have a negative sign here, when this is multiplied, so minus 8 by 3 into 1 is minus 8 by 3. So when we multiply, we get this. So bracket here. No, actually we will have this minus inside the bracket. So outside we will write plus. So when we take this minus inside, first term will be minus 8 by 3, and then minus into minus, it will be plus 8z by 3 square, because 3 multiplied with 3. And then next it will be minus, because we have plus here, minus into plus. So minus 8z square divided by 3 multiplied with 3 square is 3 cube. And then minus into minus will become plus 8. This is power 3 actually. So z power 3, okay, 8z power 3 divided by 3 to the power 3 cube you have here, multiplied with 3 is 3 power 4, minus etc. So it keeps on going like this. Now further to simplify this, now we shall gather the terms. So this will be equal to, first we will gather all the constant terms in this series. So here we have a constant term 1. So 1, and in this series what is the constant term? This 3 by 2. So gather it. So plus 3 by 2. And then in this series what is the constant term? This 8 by 3. So minus 8 by 3. So all the constants are over. Next we shall gather the z terms, that is z terms. So plus, what is do we have a z term here? No. In this series what is the z term? This one. So which is 3z divided by 2 square. And we have a negative sign before that, which we will write here. And that's all. Here what is the z term? So that is plus 8z by 3 square. So this is the z term. So it's done. So these terms are done. Now next we shall gather the z square terms. So what is the z square term? It is here. So plus 3z square by 2 cube. And what is the z square term over here? This term. So minus 8z square by 3 cube. Next we shall gather the cube term. So here this is the cube term, which is plus minus 3z cube by 2 to the power 4. This will be 2 power 4, because here when you multiply this 3 by 2, 2 multiplied with 2 cube is 2 power 4. So divided by 2 power 4. And what is the z cube term here? This one. So plus 8z cube by 3 to the power 4. So this keeps on going like this. This is a series. So that is equal to, now we shall simplify this. So what happens to this term? In this term, the LCM is 6. And so it will be 6 plus, so multiplied with 3. So 3 times is 9, minus 3 2 times is 6. So multiplied with 2, 8 2 times is 16. So I have just taken the LCM. So 6 plus 9 minus 16 by 6. Plus, now in this term, let me take the z outside. So it will be minus 3 by 2 square plus 8 by 3 square multiplied with z, because z is in common for these two terms. Now in this term we shall take z square in common. So plus 3 by 2 minus 8 by 3 multiplied with z square. And this is 8 by 3 cube. And this is 3 by 2 cube. And then in this term we can take z cube as common. So it becomes plus minus 3 by 2 to the power 4, and then plus 8 by 3 to the power 4 multiplied with z cube, plus etc. So now what happens is, this is 15 minus 16, which is minus 1. So this term will change as minus 1 by 6. So this term is minus 1 by 6. Now we want to find out a general term for all this, so that we can write it as a summation. So what we will do, in order to find the general term, we will consider this term as T1, and this term as T2, and this term as T3. So actually what is T1? T1 is the coefficient of Z. T2 is the coefficient of z square and T3 is the coefficient of z cube. So we will take and write this separately and we will generalize, and then finally we will substitute in this series. So first we have coefficient of z, which I am writing as coefficient of z power 1, which can be written as T1 is equal to, so T1 is what? Here we have minus 3 by 2 square plus 8 by 3 square. We will rewrite it as, first we will write 8 by 3 square minus 3 by 2 square. So this term we will have as it is. Next we will write T2, which is the coefficient of z square. So the coefficient of z square is T2, which is equal to 3 by 2 cube, okay, minus 8 by 3 cube. In order to write it in this form, we will take the minus out. So minus 1 multiplied with, so now it becomes 8 by 3 cube. This term comes first, minus 3 by 2 cube. Now we shall write T3, that is coefficient of z cube. So coefficient of z cube is T3, which is equal to minus 3 by 2 to the power 4 plus 8 by 3 to the power 4, and so this can be written as 8 by 3 power 4 minus 3 by 2 to the power 4. So that if you see, all will be of similar type. 8 by 3 square minus 3 by 2 square, 8 by 3 cube minus 3 by 2 cube, 8 by 3 power 4 minus 3 by 2 power 4. Except being the signs, so here it is plus 1. So here it is minus 1 and here also plus 1. So this is how we have. Now, since we have alternatively positive, negative, positive, we have to redo it by taking up a negative sign or negative 1 out, whose power will make it positive or negative depending on the powers. So in general, when we write, now we will generalize this coefficient of, generally we will have power n. So here power 1, power 2, power 3, it keeps on going like that, and in general we will have z power n. So what will be Tn? Now we will write using this form. So Tn will be equal to the outer negative 1 power. I will decide it. Before that I will write whatever is there in the bracket. So in everything 8 is the numerator. So 8 divided by, so when it is z power 1, here you have 3 square. The power is raised by 1 for 3. When you have, when you have z power 1. When you have z power 2, here the power is 3 power 3. And when z power 3 we have, it is 3 power 4. So the power of 3 and 2 are raised by 1 more than this. So here if you have z power n, it will be 3 to the power n 3 raised to the power, n increased by 1. So n plus 1 minus 3 divided by 2 to the power n plus 1. So this is the generalization of the terms inside the bracket. And what about the outside? Outside you have to have a negative 1 to the power. Now if you see, here you have plus. So if you want plus 1, you should write it as minus 1 square, because the power of 2 and minus 1 power will be same. So it will be square. So when you see minus 1 square, it will become plus 1. And here we want power, so it should be actually minus 1 power 2. Here we want it as minus 1, so minus 1 power 3. And here we want plus 1, so minus 1 power 4. So it goes on like that. I want to match it with the powers of the denominator. So in general, if it is 2, it is here also 2, 3, here also 3, here 4, here also 4. So this becomes n plus 1. So this will be n plus 1. So this is how we have to generalize the terms. And the value of n ranges from 1 to infinity. We want to write this now, actually, this series. Here first term is minus 1 by 6. So we will write that. So I have taken and I have written what we need. The first term is minus 1 by 6. So let me write that. So minus 1 by 6. And then plus Now I have generalized this. So I can write it as a summation. So summation, the value of n varies from 1 to infinity. So n equal to 1 to infinity, and the general term is what? Tn, which is minus 1 power n plus 1 multiplied with 8 by 3 power n plus 1 minus, 3 divided by 2 to the power n plus 1. Now if you give values for n, you will get each of this term. You can try it reversely and you can check whether your answer is correct. So, and these terms are multiplied by z power n, because first when n is 1 it is z, then z square, z cube, so it goes on. So tn term will be z power n. So it has to be multiplied with z to the power n. So this is the required Taylor series expansion, and this expansion is valid in the given region. So what is the given region? It is modulus of 2 lesser than modulus of z lesser than 2. So if you see, the given region is modulus of 2 lesser than modulus of z lesser than 2. So this is the region. So the given the obtained Taylor series expansion is valid in that region. So I have written that. So I hope you would have understood this problem. This is one of the significant problem in the examination point of view. So kindly go through it step by step for better clarity. Thank you.